Hello everybody, how are you?
Well, fine, sir.
Very fine. Purnima, there she came here what a collector is. Okay. Who presented yesterday?
Albert Einstein.
Albert Einstein presented about universe, right? About universe. So what it was discussed, it was written in the form of note. So let me welcome on the stage Nirajan Bhatta with his note copy and read it thoroughly so that there will be inculcation once again. And
Okay, sir.
I will clearly.
Okay, sir.
Don't say.
The universe is inherently fascinating, and its mysterious phenomena have always fueled human curiosities, inspiring exploration and the quest to unveil its secrets. Gravitational force and the universe. The gravitational force or gravity is a distant active force that exists within atoms and their particles. Gravity acts to pull bodies in the universe toward each other, affecting both mass and energy, such as light. Although gravity is invisible, its effects can be lifted and measured. The potential of gravitational force in the universe can be visited as given below: formation of new stars and planet, orbit of planets and satellites, origin of energy in the core of stars or nuclear fusions, death of stars, maintenance of size of stars, expansion of the universe, origin of universe, Big Bang theory. In the beginning of the 90s, many scientists believed that the universe is scientific or unchanging. In 1915 AD, Albert Einstein proposed the theory of relativity, which was based on two principles: no single can travel faster than light. The laws of physics are the same everywhere in the universe for all the observers traveling at the same speed. Thank you.
I think he prepared more about that. Really, Einstein met him, didn't come yesterday. Did you come? I will loudly, eh? Thank you, everyone.
Namaskar everyone, good afternoon to all. I am here from Newton Group to explain about the topic, to read about the topic universe. Big Bang Theory. In 1755 AD, German philosopher Immanuel Kant suggested that the planets and suns were formed in the same way. In 1976 AD, French mathematician Pierre Simon de Laplace proposed that the sun and the planets were formed from a spinning cloud of gas called a nebula. In the beginning of 90s, many scientists believed that the universe is static or unchanging. In 1915 AD, Albert Einstein proposed the theory of relativity. However, this couldn't be demonstrated in 1915, so Albert altered this equation to describe a universe of constant size. In 1929, American astronomer Edwin Hubble observed with the 100-inch Hooker telescope established on Mount Wilson. He also explained relation between velocity of galaxy and their interdistance by plotting a graph.
In the um, German philosopher
Philosopher.
Friedrich
What?
Edmund Cattell supported that the planets and sun were formed in same way. In 1976 AD, France mathematics uh, mathematics Pierre
He's reading same thing. What is that? The points, major dates you must remember. So here we must remember about whom? Immanuel Kant. What did he do? He was the first person to say about the history of solar system or formation of sun, right? So, uh, but his saying was, what was that? He said planets and suns were formed in the same way. You are the first person to say, but it was slightly proposed by that modified by whom? Pierre Simon de Laplace. Must be if DE comes, then that type of person is French scientist. Okay, French scientist, French. He said sun and the other planets were formed from a spinning cloud. What is it called? Nebula. And till 1900s AD, all the scientists they believe that, what do they say? The universe is static or unchanging, no change at all. It is constant. But later on, Albert Einstein gave one theory of relativity. There are 2 points. We'll discuss that one. And that theory of relativity, what does it suggest? What does it say? He said that the universe is expanding or changing. It's going away and away. And next thing, it was proved by Hubble. We have to remember this person's name, right? What is his name? Edwin Hubble. Hubble's theory will come there. Hubble's equation also will come later on. In next slide will come. So Edwin Hubble, he observed the different components of universe with the help of telescope. Where was that telescope kept? In Mount Wilson. And what did he say? He said the galaxies are going away with high speed. He showed the distance by plotting in a graph. So here, one thing I have to remind, Albert Einstein, he gave, what did he give? Theory of relativity. There are 2 points. What are the 2 points of theory of relativity? Nothing can travel faster than light. Nothing can travel faster than light. I think this is the one. So, what is the page number? 283. Because there it will be difficult. 283. In the page? Here are 2 points. How many points are here? Yeah, these 2 points are based on, means these are the explanation of theory of relativity. What is the first point? No signal can travel faster than light. Okay, it was said by him. It is true also. What is second one? The laws of physics are the same everywhere in the universe for all the observers traveling at the same speed. It is applicable for everything throughout the universe. This is the thing we have to remember. And you were talking about, what did you talk? Edwin Hubble, American astronomer. He has got very big telescope, 100 inch. 100 inch means that lens diameter was 100 inch. That much big. And name of the telescope was Hooker telescope, kept in Mount Wilson. And he gave one relation. Edwin Hubble, he gave one relation. What is the relation? V equals to HD. So what is V? Velocity of galaxies. That means galaxies are going away from each other. Then what is D? Distance between them. And what is H? Hubble's constant. What is H? Hubble's constant. Remember the formula. One new formula is there. We are not going to do any numerical problem, but we have to remember the terms, their SI unit. Okay. So what is the value of Hubble's constant? 73 kilometer per second per megaparsec. What is this? Per megaparsec. Parsec we have studied earlier, but you forgot. Actually, distance is expressed in a light year, astronomical unit. Look at his style. He is doing like this. He is looking up. Hubble's telescope, you can see their ceiling only is open. Then like just he tied his this what you say zipper and kept that chin down. And dreaming about some other activities or what? Be careful, boy. Isn't it? Your Maramat, I think it's not up to date. There will be I Maramat. Nowadays, B Maramat is very famous. Balin Maramat. Balin Maramat is very famous around. Everywhere there is Maramat. Now, I mean, Ishwar's Maramat also will come there. I Maramat. Okay. So, the distance between Sun and Earth, that is expressed in AU. AU, astronomical unit, is shorter one. It doesn't take 1 year to travel the light, right? So, if it takes 8 minutes 20 seconds, 8 minutes 20 seconds or 500 seconds. So, a bit longer one is light year, but more long distance is expressed in parsec. So, remember the value 73 kilometer per second per mega parsec. And okay, now next slide is here. What is the slide now? Here you can see this is the Big Bang theory. Like here, small dot slowly expanded and everything's are formed over here. I think human beings are here. We are here right now, but later on what will happen? We don't know. Now, other persons, what do they say here? In 1927 AD, George Lemaitre, he was also a very famous person, eh? George Lemaitre told that universe just started as a single point at which a function takes at an infinite value especially. You are the person to tell about Big Bang theory. When matter is infinitely dense, much like at the center of black hole. The matter was very dense, like small point, but slowly it started expanding and expanding. And afterwards, in 1729, Edwin Hubble observed that other galaxies were moving away from us. He proved it. That's why they are going far away. Means expanding universe, we can say. What do you call it? Expanding universe. So what is here? When universe began, it consisted of hot, tiny particles mixed with light and energy. A star contract to its current form. Over the 14 billion years, the universe evolved into still expanding cosmos we know today. So it says that the age of the universe is only near about 14 billion years, but still it is expanding. It is going away from each other. The Cosmic Background Explorer satellite launched in 1991 confirmed that background radiation field has exact spectrum predicted by the Big Bang origin for the universe. So they have launched some satellites. Those satellites also observed about the expanding nature of universe. Okay. Now I think this is the last one. On this much, only that is done, and thank you. So I told which page number to do. Let me check over here. You know, black hole is more powerful or sun is more powerful? Black hole is more powerful also. It may be smaller than sun. Black hole may be smaller than sun, but the mass is in dense form. The density of black hole is 1,000 times more than that of the sun. So here this Big Bang also occurred like that. There was a dense mass, very small mass, but it started expanding and came to this one. So Lemaitre, you have to remember this one. This is blasting. Okay, now I think next person is going to discuss about conclusion of the Hubble's study about the motion of heavenly bodies. So whose presentation will be there after this? Heisenberg, Susmita, and next Susmita, Joy. Good. So be prepared yourself, eh? Understood or not? I think Sushmita is going to read and you are going to explain. That's very great. So today we have to complete that much. Right now, which page number's work is completed? Page number 282, 83, 84. Please go through it once again and make your notes. Clear? Okay. My dear students of grade 9, how are you? Sometimes you are very happy, sometimes not so much happy. Pandu. Sometimes you say bye bye also. Handshake also. So many uses are there. Mixing the food also. Eating also. Sometimes Pandu work also will be there. Understood or not? That's why. Sometimes slaps also. Okay. And now I will call the person who has done that note work, who has completed up to difference between EMF and PD. You have completed? Okay. So let's welcome on the stage Anmol Adhikari to read the note. Everybody just listen carefully. This electricity channel. Electricity channel. Okay, a bit loudly. Eh? Oh no, right. Come this side.
Note, Namaskar and very warm good morning to everyone. It's me, Anmol Adhikari. Good afternoon to everyone. It's me, Anmol Adhikari, standing here to read the note. Note: electricity is one of the main source of energy. Today, it is flow of electric charge which can be transported from one place to another by using conducting wire. Electric current. All the bodies of the universe consist of atoms which contain subatomic particles like electrons, protons, and neutrons. Among these particles, protons are positively charged and electrons are negatively charged. Also, neutron is chargeless. The rate of flow of charge in a circuit is called electric current. The amount of energy converted from non-electric energy into electrical energy by the source of electric current is called electromotive. For electromotive energy, then its SI unit is volt. If electric source supplies Ij energy to produce IC 1 coulomb charge, the EMF of the source is called 1 volt. Difference between electromotive charge and potential difference. It occurs in the internal circuit. It occurs in the external circuit. Its value is greater than the same value of PD of the same circuit. Its value is lesser than the value of PD, and it is measured in open circuit and it is measured in closed circuit. Thank you.
Thank you. So actually we have to repeat time and again what we have discussed. So let me show you once again in this. Um, Google Chrome is already open. So I will just check it. Okay. Modern graded science. Modern graded science. 9, right? It is the one. Is it ours or others? No, it's not ours, right? And science 9 final, where is it? It's here. Where is it? Is it open? Sometimes it's open. Page number? What is the page number? 190? 95. Oh, okay, so you can see here the device. What is this device? Emitter. Emitter. What does emitter do? Emitter measures the current. It measures the current. How is it connected to the circuit? in series combination. What is it called? Series combination. Okay. Then sometimes it does. Okay. Oh, here was scrolling. Why am I not using this one? What's over here? Right? So you can see here subatomic particles. At the center, there are proton and neutron. Proton is positively charged, neutron is chargeless, and electrons they lie at the periphery. They are very light bodies, so they can move from one place to another. When electrons move from one place to another, then there is electricity. What is there? Electricity. How do you define electric current? The rate of flow of charges in unit time. Rate of flow of charges in unit time is called electric current. You can notice here, this is the source of electricity, this is battery, here is plus, here is minus. Charges flow from minus to plus. In minus, there is high potential, in plus, there is low potential, so they flow from high potential to low potential. And how many type of circuits are there? Basically, there are two types of circuit. One is open circuit, another is closed circuit. But sometimes there may be short circuit also. What is there? If the two wires are connected directly without any load, then that is called short circuit. So you are talking about this brain Franklin activities, J.J. Thomson's. You must remember, what did brain Franklin say? He said charges flow from positive terminal to negative terminal. J.J. Thomson, what did he say? Travel from negative to, because charges, negative charges are flowing, not positive charges. J.J. Thomson. In morning class, there was differences between EMF and PD. EMF and PD. How many differences are written there? Five differences? Okay, five differences, right? Okay, here is given 1 volt equals to 1 joule by 1 second. 1 joule by 1 second. 1 joule by 1 coulomb, not second. Coulomb in charge. This is the difference between EMF and PD. Now, in this presentation, they are going to explain about electric resistance, conductors, semiconductors, insulators. Then here there are some rules. R directly proportional to L, inversely proportional to area, resistance, this numerical problem. I think up to there they may be doing. So let's welcome on the stage the presentators. Who are the presentator? Sushil and Mohan. Anmol. Oh. Anmol, not king now. What type of king is it? If he says king, I will give one to slap now. Okay, please come on the stage. Rest of others pay attention. So their presentation will be of maximum 15 minutes. And afterwards, minor discussion and what will be given to you. Now pay attention.
Animation. Namaskar and very warm good afternoon to you all. It's me Sushil Chand from Group Tesla, standing here to read some portion of chapter electricity. Activity 11. Reading. Activity 11.4.
Place two microme wires of the same thickness but different length 10 centimeter and 100 centimeter. Connect them one by one in the gap PQ. Record the reading of the ammeter each time. Number 2. Now repeat the activity 1 by using two nichrome wires of the same size and thickness. At first, connect the gaps with a single wire and then by using both wires.
Repeat that. This is upper one. Now repeat that.
This. Now repeat the activity 1 with copper and nichrome wires of the same thickness and same length. Note the electric current in the ammeter when a nichrome wire is connected to the gap PQ. Then hit the wire with the help of a spirit lamp or burner. From the above activity, we conclude that resistance is directly proportional to the length of the conducting wire. R is directly
Proportional to L length.
R is proportional to L length. Number 2, resistance is inversely proportional to the thickness cross-sectional area of the conducting wire. R proportional to 1 upon A. Resistance of a wire depends on the nature of the material which is made up of. Resistance is directly proportional to the temperature of the conducting wire. R is proportional to T. When an electric ends of the electric iron of the iron to a 220 volt connected to a 220 voltage circuit, 5 ammeter electric current flows in it. Calculate the electric resistance of iron. Here voltage is down. This voltage is 220 and electric current is 5. Now we have to find the electric resistance. R is equals to V upon L or I. And V upon I, R is equals to 220 upon 5 and R 44.
So what is the symbol?
Ohm. Thus resistance of the iron is 44 ohm.
Now next question.
Now next question, calculate the electric current flowing through a 40 resistor when a potential difference of 8 voltage is applied across it. A resistance R is equals to 40 mega ohm. Potential difference is equals to 8 and current we have to find. V is equals to IR. I is equals to V upon R and I is equals to 8 upon 4. 2. The relation between the current through a metallic conductor and potential difference across its end was studied systematically by a German physicist Georg Simon Ohm in 1826 AD. This relation is now known as Ohm's law.
Okay. So now next tomorrow. Okay. Great, sir. You are saying you seeking what?
Here is activity 11.4. Place two nichrome wire of the same thickness but different lengths. Means place two nichromes of the same thickness but length is one is 10 centimeter and another is 100 centimeter. Connect them one by one in a gap of PQ. Record the reading of the ammeter each time. Now repeat the activity 1 by using two nichrome wire of the same size and thickness. At first connect the gaps with a single wire and then by using both the wires. Now repeat the activity 1 with the copper and nichrome wires of the same thickness and same length. Note the electric current in the ammeter when a nichrome wire is connected to the gap of PQ. Then heat the wire with the help of spirit lamp or burner. From this above activity, we conclude that resistance is directly proportional to length of the conducting wire, R proportional to 1, and resistance is inversely proportional to the thickness cross section area of the conducting wire, R proportional to 1 by A. And then resistance of a wire depends upon the nature of the material which it is made up of. Resistance is directly proportional to the temperature of conducting wire R proportional to T.
Okay, this much only. Because these questions are related with, let's say, after Ohm's law, some formulae we have to derive, and they just mention the uh, EMF and PD. It was discussed earlier. Now, next matter is here. Next heading is electric resistance. Electric resistance. How is it denoted? How do we denote electric resistance? Denoted by capital R. Resistance. See, metals, they allow electricity to pass through them. Suppose there is one iron rod. Keep that iron rod in ice and touch, and at the end, another end, you feel cold or not, because those that heat, hotness or coldness, it can transfer from one place to another place, because iron contains free electrons. If the body has free electrons, at that time it can transfer heat as well as electricity. If it doesn't have, it cannot. So, metals and green objects, you say green wood or green bamboo, our body, these are good conductors. Electricity or electrons can pass easily. But there are some substances, especially alloys. Alloy, what do you mean by alloy? Do you know? ALLOY. Celine, what do you mean by alloy? Alloy is the mixture of metal or metal, metal and metal, or metal and non-metal. Like in our kitchen, we use steel items, but actually they are not steel. That is stainless steel. That is a kind of alloy. So alloy, there are some examples of alloy. What are the examples? Manganese, constantine, nichrome, tungsten. They are alloys, and they have ability to block the flow of electricity. They do not allow to pass through them, and they have high resistance, we can say. In this connection, we have to remember about insulator, semiconductor and conductor. What do you mean by insulator? Those substances which do not allow electrons or electricity to pass through them. They are called insulators. Like wood. Wood is insulator or not? Stone. Pure water. Pure water is also insulator. But impure water is conductor. Impure water can conduct electricity. Semiconductor. They conduct electricity slowly. Conductors conduct very fast. Insulators do not. Semiconductors slowly. Example of semiconductor is silicon and germanium. So, what is resistance? Did you find the definition of resistance? Where did you find? Resistance is the ability or property of a material to resist or block the flow of electrons through them. The ability or property of a material to resist or block the flow of electrons from them is called resistance. Conductors, they have got low resistance because they do not block more electrons, but insulators, they have got more resistance. For that case, there is one formula of resistance. What is the formula of resistance? R equals to V by I. What is R? Resistance. What is V? Voltage, potential difference. Actually, that is voltage or potential difference. What is I? Electric current. So, this relation was first introduced by Ohm. So, there is formula. He gave this formula. V equals to, remember, V equals to IR. What is V? Potential difference or voltage. What is I? Current. What is R? Resistance. So resistance is expressed in ohm. In which unit? Ohm, and it is denoted by the letter omega. This letter is called omega, and but what to pronounce it? Ohm. Like we say, what do you call this? Theta. Yes or no? Or what do you call it? Alpha. What do you call it? Beta. What do you call it? Delta. What do you call it? Pi. What do you call it? Pi. What is it? Pi. These are Greek letters. So the SI unit of resistance is ohm, denoted by omega, and other units are kilo ohm, mega ohm, kilo ohm and mega ohm. And one experiment they have done. Earlier we used to get a kind of bulb. Nowadays we get it. When electricity passes, the wire becomes red hot and it produces light, right? Round bulb, have you noticed or not? Nowadays we have got LED. That is LED, right? But earlier we used to get, nowadays also we may get, it may be colorful, red color, yellow, green, blue, no black color because black light doesn't. A small bulb one, why not? Some are bigger also. No, not that also contains, because there must be something glowing. If there is wire, that wire has high resistance, but the copper wire, it has got low resistance. And these things you must remember. How many points are here? 4 points are there. Please read the first point. Your resistance is directly. If the conducting wire is long, resistance is also more. If short, less. What is the second one? Resistance is inversely proportional to the thickness. Means thick wire, less resistance, thin wire, more resistance. So inversely means if one increases, another decreases. What is the third one? Resistance of a wire depends on the nature of the material, how it is made up of. And fourth one, resistance is directly proportional to the temperature of the conducting wire. More temperature, high resistance, less temperature, low resistance. Hot wire has more resistance or cold wire has more resistance? Hot wire has more resistance, cold wire has less resistance. Okay, that is the thing. This numerical problem we will discuss after discussing Ohm's law. Is that clear? Now read once again. You make note. I will just check your copy. I think I might have checked your copy in morning time, right? Yes or no? You start doing your work now. Come on. Work must be done. No, diary's time will come. Choose yourself to sit in the bench or floor, because our floors are carpeted one, and people, they don't dare to walk with shoes. Their shoes are kept outside, very fresh. There is Hoover also. What coming there? Keep the bag in the middle. You connected, girls? Okay. Without wasting time, we'll discuss now class 10. Which presentation is today? Heisenberg's? Okay, Heisenberg's. It was discussed earlier. What was discussed? Theory of relativity given by Einstein. And we discussed about one scientist. What is his name? Georges Lemaitre. So he told that the universe started just as a single point, and it started expanding, right? And it was proved by Hubble, Edwin Hubble. And Hubble gave one formula also. What was that formula? V equals to hd or dh. What is V? Velocity of galaxies, how they are going. What is the distance between those galaxies or distance traveled? And what is h? Hubble's constant. What is the value of Hubble can send? 73 kilometer per second per parsec. Not only parsec, there is megaparsec, right? Megaparsec. So now Heisenberg group, they are going to discuss about conclusion of the whole study. This question is quite important because the course was modified last year only, and many times they have asked question from here. Conclusion of Hubble's study, and so see, here are these things. What did he say? Milky Way is not only the galaxy, there are many other galaxies, and the galaxies are constantly moving away from each other. So only two things he has said. There is not only one galaxy, there are many galaxies, and they are going away from each other. Edwin Hubble. And we use very big telescope, right? And a future of the universe is also given here. Means closed universe. Next one, open universe. What is the next one? Flat universe. I think they may be going to do this one. This graph is also quite important. The graph shows, now see, if it goes from here to here inch, means what is that? Closed universe. That is also called Brightons. And if it goes bigger one, much more, that is open one. And from middle, what is that? Flat universe. So open universe continuously expanding, and flat universe expansion but a bit slowly, and closed universe no expansion, stop expansion. So I don't know what other things they are from Heisenberg group. Miss Susmita Buddha and Jai Kumar Sharma. Please sit down correctly, everybody get that straight and focus on that. Okay, miss? Sound must come loud. You take a sound from
Latin.
and I think it's better to download. Yes or no?
Yes, sir.
Okay. Yes. Slowly.
Namaskar and good evening to good afternoon to you all. As you all know, it's Mrs. Buddha and group Eisenbot. And in the subsequent series of the papers with Max Born and physicals drawn during the same years, his matrix formulatics of the um, formulative of Fresenic acid was sophisticatedly elaborated. He is known for the uncertainty principles, which the uh, published in 1927. Heisenberg was awarded the 1932 Nobel Prize in Physics for the creations of quantum
mechanics.
and mechanics.
What is this?
The
What is how is it made? How is it?
the universe is
Yeah.
Conclusion of Humble's studies about the motions of the heavenly body. Humble's made a
You have to make like
Christian discovered by nothing that the research of galaxy in inserts informing uniformly with their increasing distance from the Earth. Earth in other words, the universe appears to be expanding as implied by uh, Einstein's theorem.
So Hubble made a curious discovery that the redshift of galaxies is increasing uniformly with the increasing distance from the Earth. In other words, we can say universe is appearing to expanding. It is expanding as implied by Einstein's theory.
First, Humble figured out that the Milky Way is not the only galaxy. Second, Humble discovered that the galaxies are constantly moving away from each other.
So Hubble figured out that there are not only Milky Way galaxy, there are other galaxies too. And second, he discovered that the galaxies are constantly moving far away from each other.
Future of the universe. Our ability to predict the futures of the universe is
Contained.
contains in
Is constrained.
constrained by the extent of our observation. Observations. The figures in this the evaluated of the universe over 13.7 billion years. The Big Bang is depicted on the left side of the figure, followed by the period of the exponential growth.
So we can predict our future of universe by the observation. Okay, in this figure you can see the universe has expanded many more from the Big Bang. From the Big Bang, it is now 13.7 years old. Our universe. Next.
these are quite important. Okay, these three types.
A closed universe. If the density of the universe is greater than critical density, gravity will be strong um, enough to stop its expansions and eventually reverse it. Is a triangle drawn on the surface of the spheres as an angle um, whose sum is greater than the 180 degree.
So we know our universe is expanding constantly, but if the density of universe becomes greater than the critical density, then gravity will be strong enough to stop its expansion, and eventually it will reverse. Means it will start to contract again. And there is a triangle drawn here whose sum is greater than 180 degree.
Thank you very much. I think in their PowerPoint, there is only one type of galaxy, right? What is that? Closed universe. And there are other two type of universe that will be discussed in another presentation. There is open universe as well as flat universe. So children, look at here. They have said one thing here. critical density. What is here? Critical density. What is critical density? Sometimes question can be asked, defined. The average density of matter in the universe at which gravity is just sufficient to halt its expansion. It means it does not allow it to go away. So gravity is just able to stop its expansion. So that is called critical density. On the basis of critical density, there are three types of universe. So here is given one closed universe means, see, this is the universe one. So slowly it goes and it just contracts and comes to end. Now this type of universe is, what is it? Closed universe. In closed universe, what is there? What is here? Density of the universe is greater than critical density. Universe density is greater than critical density. And now here is another also. In open universe, what is there? Density of the universe is less than critical density. Next one, in flat universe, density of universe is equal to critical density. One more, one less, one equal. Accordingly, there are three types of universes. So diagram also you can notice here. So here, density of the universe is more than critical density. In open, less than critical density. Here equal to critical density. These things you have to remember. Okay. Now once again, please go through the book up to open universe and or up to flat universe you can read. Then you can make note yourself. Is it okay? All right. And tomorrow, whose presentation is there? Which one? Whittaker. Where are the members? Whittaker, Sonis, Luniva's presentation I have seen, Simras also I have seen. Only your presentation left. One more also there. Then you.